Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about mass storage structure. In that mass storage structure, we have seen about magnetic disk, solid state drives, and next is magnetic tapes. So in this session, we are going to discuss about disk structure. So let us see about this disk structure. So overview of this presentation is we are going to say about the disk structure. So disk structure. Disk surface divided into n number of tracks. So this disk surface is divided into tracks. A read or write head positions just above the disk surface. So these are n number of tracks which are placed in the disk surface, and the read write head position just above the disk surface. So read write, this is the read write head where the position just above the disk surface. So it is placed above the disk surface, read write head position. So information stored by magnetic recording on the track and the read write head. So the information is stored in the magnetic by recording on the track which is placed on the head of read and write. So that is fixed head disk and moving head disk. So there are two fixed, one is fixed head disk and other one is moving head disk. Designed for large amount of storage for binary tree in data structure. So it is placed in large amount of storage and that can be used for binary tree in data structure. Primary design consideration: cost, size and speed. So some primary design considerations are cost, size and speed. So this is what disk structure. So here these are the tracks, n number of tracks, and there is one cylindrical shaped and one is sector. So this is what spindle, and this is arm assembly. So this is arm assembly. There is a read write head and this is arm. So how the disk structure works: the platter of this and n number of tracks and sector and cylindrical shape and spindle, and there is one arm assembly, and there is another one is read write head, how the position of read or write head is placed. So first, hardware for disk system. Hardware for these disk systems are used is disk drive, device motor, read or write head and associated logic. So this hardware of disk system consists of disk drive, device motor and read write head, and another one is associated logic. What is disk controller used? So disk controller determines the logical interaction with the computer. So the disk controller can interact with the computer directly. So this control may be done through disk. Can service more than one drive. So it can use the services for one or more drives, and they are overlapped 6. Cylinder: the same numbered tracks on all the disk surfaces, the same number. So here the same number of disk cylindrical, the same number tracks on all the disk surfaces. Each track contains 8 to 32 sectors. So these are maybe 8 to 32 sectors. So nothing but cylindrical. In this cylinder we are having for each track it consists of 8 to 32 sectors. That is what in cylinder. And next, sector. What do you mean by sector in this disk structure? Smallest unit of information that can be read or write. So the information is very small and it is in the read write head position into the disk, and the range from 32 bytes to 4096 bytes. So 32 to 4096 bytes are kept in this range for each sector, and that can be read or write into the disk. This is what about sector. Next, how the disk performance parameters are done. Some important parameters used to measure the performance of hard disk are as follows. So, they are measured in some performance. What are they? Let us see. Seek time, latency or rotational delay, data transfer rate, data transfer time, and average access time. So, how these disk performance parameters are used to calculate? Based upon seek time, latency or rotational delay, data transfer rate, and disk data transfer time, average access time. So, let us see this seek time. In this seek time, the time required by read or write head to move for the requested track. So, whatever the track which is moving from head read to write, that are requested for each track, that is what seek time. Includes the initial startup time and the time required to traverse the tracks to be crossed once the axis arm is upon to speed. Here, how the seek time is calculated. So, the time required which is required by read or write head to move the requested track. So, once the track is requested with the read and write, so the track of that seek time is completed. So, it includes some initial startup time and required to traverse the tracks and cross to the axis arm upon their speed. So, whatever it is used upon the speed, that can be calculated by startup time by reversing the tracks or traversing the tracks. That is what about seek time. Next, latency or rotational delay. So, what do you mean by latency or rotational delay? The time required for the requested sector to come under the read or write head. So, in this, whatever the time required for each sector to come under some read or write head, and the rotational delay is generally the half of the time taken in one rotation. So, the generally is one half of the one rotation. So, after one rotation, half of its time taken is based upon the rotational delay. So, half of the time in one rotational, that is what rotational delay or latency. And what do you mean by data transfer rate? In this, data transfer rate is defined as the amount of data transfer in per unit, for example 30 MB per second. So, whatever the data which is transferring the data per unit, for example it may be 30 MB per second or it may be more than that. So, how we are going to transfer the data from one system to another system, and the unit time is based upon 30 MB per second, for example. And data transfer rate. How we are going to calculate this data transfer rate? The data transfer time is total time taken to transfer a specific amount of data from the disk. So, here the data transfer is nothing but total time taken. So, the total time taken, and it is used to transfer some amount of data from each disk. So, total time and total time amount of each disk. And next, data transfer time depends on the data transfer rate of the disk. It depends on the data transfer rate of each disk. This is how we are going to transfer the time of disk. Next, how we are going to calculate this average access time. Average access time is calculated as average access time equals to seek time plus rotational latency plus data transfer time. So this is how we are going to calculate average access time. Average access time equals to seek time plus rotational latency plus data transfer time. This is how we are going to calculate the average access time. So this seek time, latency, data transfer rate, data transfer time and average access time, these all are used for our disk scheduling algorithms, which we are going to see in the next session. So in this session we have seen about disk structure and how we are going to calculate the seek time and what are the parameters and how we are going to calculate the access time. So this all are we have discussed in the disk structure. If you have any doubts, you can comment in comment box. Thank you.